So there is one thing that remains to be discussed, which is the kinetic energy of a rotational system. We already know that kinetic energy for a translational system, that is for object moving in a straight line or moving with some velocity, is given as half mv squared. Some particle of mass m is moving with the velocity v, then this is what kinetic energy is. Now the corresponding formula for the rotational Ke is, you can actually guess, m gets replaced by I and v gets replaced by omega. And this is the case. Let's say this is the system, it's moving with omega and it has a moment of inertia I. This is what it is. Let's give some basic formulas regarding I's. For a ring of mass m with radius r, I is given as mr squared. We do not have to derive I every time we solve a problem, so we can just memorize them. For a disk of radius r and mass m, I is mr squared over 2. Excuse me. And for a stick about this axis, we already have calculated. I is given as, this is the length L of mass m, ml squared over 3, but if you hinge it in the middle, then I is ml squared over 12. We already have calculated for the case when there was a triangle. This is L, the mass is m, then we knew that about this axis I was ml squared over 2. So given these, and if these guys are moving with angular velocities omega, all we have to do to calculate kinetic energy is multiply half I and omega squared. So you can clearly see this guy has less kinetic energy, which is moving at omega, than this guy. You can clearly see this can do more damage than this guy, which has the same length. I should have told this is the same length as the previous one and the same mass as the previous one, the same ruler. Just we have changed the axis about which the whole thing is rotating.